Hi, welcome to a video where I attempt to explain why I made Terramorph and how Terramorph is supposed to work, what the problem statements were, and how I kind of went about trying to address some of those problems. The first, and probably the easiest one to talk to, is the advantage of having version pinning in your Terraform environment. So if you imagine that you have multiple developers who are all writing Terraform code, and you have like Bob on 0.8, and you have Lisa on 0.9, and then your build environment is on who knows, and Terraform is coming out with new features that are either buggy or not supported in older versions of Terraform. I've been using Terraform for a really long time, back when it was pretty buggy, and also back before we had cool things like remote state. So being able to version pin Terraform so that you don't have a whole bunch of varying versions out there on your team and your build environment is extremely valuable. The other problem I wanted to solve is exposing Terraform to Windows environments. So I previously came from an enterprise level organization where we had neat little dev teams that were, running Macs and familiar with Windows and Unix environments, and so we were all using Terraform natively. But we had other teams that were trying to make their migrations to the cloud, and we had a slightly slower uptick in adoption within those users because they were on Windows machines. They had historically been on Windows machines. So while the Terraform code itself is very easy to write, and we could whiteboard AWS environments, if we wanted to get buy-in on that, we had to make it approachable and easy to them. So that's the second problem statement. The third is that since I mentioned I've been using Terraform for a long time, our early code bases were a mess. It was just like tons of files in one directory, right? Which meant that your Terraform apply touched everything, had lots of cascading dependencies, and meant that if you made a change, it's possible you could have unintended side effects from that change. And then layering came around. And so now we have layering with immutable resource references. So you can build up like your network layer and then put like maybe your DB layer and then an application layer in a specific order, and they could each kind of reference one another. And then if you're going to make changes to your application layer, the application layer changes would be unable to make any changes to like your database layer, but it would, with a remote state resource, be able to reference attributes from the resources that were created in the other two layers. This is great. And if you left it there, if you didn't get any more complex than that, it really would not introduce any additional complexities to the use of the tool. I mean, it's not really too cumbersome. If you, however, start segmenting out your code base, so if you have a network layer that has like VPC and maybe a proxy, maybe some additional web security features, that would be a complex layer. And then your next layer up, DB, well, if you had multiple, if you were going like with a microservice design or something, and you had multiple database sources, that would increase the exposure for that particular layer, and so on and so forth with the one or perhaps multiple application layers. So instead, what we can do, I promise I'm going to make like a picture or something to kind of demonstrate what I mean by this visually, because the visuals help a lot, is take those layers and slice them up and segment them. So if you have a network layer, then you can have multiple segments within the layer that are their own self-contained code bases. And the layer, these segments within that layer would have no cross-segment dependencies. What I mean by that is that it is ideal to consider the order of execution when you're kind of building like a segmented or layered Terraform code base like this. Um, a real-world use case for a design like this is that in that previous enterprise that I was working in, we were trying to get remote teams more involved in developing and supporting the cloud resources that we were building and the Terraform code base that we were using to build and maintain those cloud resources. Well, the remote teams we were working with, one, weren't terribly familiar with Terraform, and two, even if they were familiar with Terraform as a tool, they weren't familiar with our code base of Terraform. And so a big push on my part and my team's part was, how can we make this easy and approachable? How can we make this safe to encourage people to get involved without that terrible fear that I'm going to screw something up, which, I mean, if you're watching this video, you probably have. So limiting the blast radius of changes to a cloud infrastructure code base is a great way to address that. So that way, if somebody is attempting to modify application X, they can go into the code base for application X and make a change that not only is less likely, but it's impossible to have that affect really any other resources, unless, of course, there are downstream dependencies from application X, right? Not much we can do about that. So that's great, but it introduces a new challenge. And the new challenge is, how the hell do you spin that up? Like, let's say we've got a multi-layer, multi-segment environment that is complex and requires someone to walk through or navigate these layers and these segments and in a particular order. Now we need some sort of a runbook or a playbook. Well, the way that you can solve that is, well, at least the first way I thought of solve it is an Ansible playbook. So I built a playbook layer that will kind of tie that all together, but I'm getting ahead of myself. The other challenge that I wanted to address was that I wanted this, in addition to being cross-platform, it couldn't just be a Docker container, because executing Docker containers are, very often like long strings that you don't want to have to bother with, if you're going to use it repeatedly. So to me, that meant this needs to be some sort of an aliased command. And the installation setup of this had to be just really simple. I don't think I was going to get, well, I might not get buy-in anyway, but I don't think I was going to get good buy-in or investment from people if it was in any degree a complex setup. So those are kind of the use cases, problem statements, goals of the project. The way that I ended up approaching the solutions for that was that it is a Docker container that is run via alias commands in either Mac, Linux, or Windows. The setup process is simply running a single file once. The requirements are Docker, and that's all. You can run it in a... let me pause. I forgot one requirement, or excuse me, one more use case. The other use case that I hit, or that I wanted to address when I was building this, is that moving from environment to environment in Terraform is not as elegant or carefree as I would wish it to be. What I mean by that is, if you're working in dev, being able to switch from dev to lab to stage, etc., required editing files in kind of a clunky way and had the possibility of things like state pollution. In fact, if you'll read the kind of like Terraform up and running book, which I have over there on my bookshelf, I can't remember the exact name, but if you read that book, the way that they address environments is that they actually instantiate modules repeatedly just for environmental purposes. And this seems clunky to me. And then you've got files like code blocks like the Terraform code block, which can't have variable instantiation within it, to address things like what your Terraform remote state key path is, like in an S3 bucket or something. So let's talk about that really quickly, because that's an interesting one. The way that I decided to go about trying to solve that is that what you're left with after a Terraform init is a .terraform directory within the working context that you're in. If I use that word context, I just mean the current Terraform codebase segment layer, whatever, wherever you're currently working at. So you're left with this .terraform directory, and the .terraform directory contains things like your imported modules, your terraform.tf state file, which is very often just the metadata about the remote state storage location, like S3. But it's very important, and if you get that screwed up when you're moving from environment to environment, you can cause a lot of confusion that should get caught by a plan, doesn't always. So how to address that? Well, the approach that I went with was this concept of a Terramorph library. And what this library does is, instead of a .terraform directory, you have a .terramorph directory. And then within that, you have an environments directory. So let's say we're working on the VPC segment. You'll see a .terramorph directory, and you'll drill down to environments and then dev. Dev is your .terraform directory. And when you do a run, Terramorph will check out that dev directory out of the checkout, right, like quotes, out of the library into the current working context and rename that directory .terraform. It will execute all of the commands that it's attempting to do, and then once it finishes, it will check that .terraform directory back into the library as whatever environment you're currently working in, so dev, stage, prod, whatever. Thus, leaving you with a completely sanitized working environment. So there is no .terraform directory laying around, and if you were going to change environments by reconfiguring your environment variable of tm underscore env, env, and you change that from dev to lab, then what it would do is it would attempt to check out the lab environment into the current working context and execute that way. But it really makes it impossible to have any sort of state pollution or misconfiguration moving from environment to environment. So anyway, I can't quite remember where I was in talking about how I decided to address that. But here are the key points, and then we can probably just wrap the video up. One is the setup had to be easy, so one script, and the use had to be easy, so an aliased command. Two is it had to be completely and totally self-contained. I didn't want installation dependencies. I didn't want version drift from person to person or build environment. Three, it had to address complex, layered, and segmented working environments. And four, it had to leave you with a clean state every time it finished its execution. And I guess there's one last thing I want to talk about, and that's that often in enterprise environments, the different environments are represented not only by like a different VPC, but an entirely different AWS account. So moving from dev to lab to stage to prod PCI also will often involve switching AWS accounts. And that's kind of another value of this tool, is that it's set out from the beginning to work with your AWS credentials file in your home .aws/credentials path, which will allow you to really move from account to account really easily in a really clean and understandable way. And I think as more organizations move that direction, they're going to look to their kind of cloud infrastructure automation tooling to start not at the account level, but above the account level, from the, whatever you want to call that, objective level. So I think that pretty much wraps up the problem statements and the way that I attempted to solve those problems. I hope this was useful and not too wordy. Didn't have any sort of script that I was reading off, and I'm not going to edit this at all. So hope it doesn't suck. Thanks for watching.